Hello guys. So today we are here to solve this problem called count number of teams. And in this we are given n soldiers standing in a line. So there are n soldiers and each soldier is assigned a unique rating value. So we have to form a team of three soldiers amongst, we have to form a team of three soldiers. And the condition is that we have to choose the three soldiers with the index ijk such that I is greater than equal to 0. So I is, I can take value of 0, but j should be greater than I and k should be greater than j. Okay. Obviously, k has to be less than n. Okay. The number of soldiers, the total number of soldiers, k has to be less than the total number of soldiers. But I should be, I can be equal to 0 and j has to be greater than I and k has to be greater than j. Okay. And I and j and k, obviously they can take values between 0 and n. But the condition is that j has to be strictly greater than I, k has to be strictly greater than j. And also that the rating should of I should be less than rating of j, or rating of j should be less than rating of k, or the reverse. Either the rating of I is greater than rating of j, or rating of j is greater than rating of k. So this is the condition here. Now, to solve this problem, see, there are some very obvious ways that we can handle this problem. So what we can do is that, we can initialize one count variable, okay, and n is equal to rating dot length like this. And then I is less than n plus I for and j is equal to I plus 1, j is less than. So let's, I should be less than 2, j should be less than n minus 1 and plus g. And for int k is equal to j plus 1, k should be less than n minus 2 plus k. Okay. And the condition is that if rating of I is less than rating of j and rating of j is less than rating of k. So this is one condition. Okay. And then we can take another condition, or rating of I is greater than rating of j and rating of j is less than rating of k. Then in this situation, what we are going to do, we are going to increment the count value. Okay. And then at the end, we are going to return this count value. Let's see whether this solution is accepted or not. Wrong answer. Why it is wrong? Oh, it should be n. Perfect. Let's submit this. So it's accepting, but you can see that it is, not very efficient. Can we do something here? Let's try doing something here, okay? If rating of J, but these numbers are, distinct. They are given to be distinct, okay? So nothing is equal. So equality check is not of any use here. Okay, so what can we do? It seems like we cannot do anything here. But, there is one idea. Let me, explain that idea first, okay? Suppose this is the array, okay? Suppose this is the array, okay? Let's say we are at this index. To the left of this index, like in this place, there are some values, and to the right of this index, like in this place, there are some values. So to the left of this index, either some values are less than, less, or some values are more, okay? Same here for this. Either some are less and some are more, okay? So what we are going to do, that if it is less, if these values are less, then these less values can be combined with m and this current value. So the count of less for each index, okay, into the count of mores. So this left side less is multiplied with this. So this will give the total number of ways that these teams can be formed. And then the count of these mores on the left multiplied with the less, this will give the total number of values which are, you know, uh, uh, can be arranged in the strictly decreasing order. So, and we can, sum these two multiplication values into the count at each index, and finally we will return that value. So this is, going to help us in creating a solution which is not in big O of n cube. Right now, this is big O of n cube. So this is, right now, it is of big O of n cube. The complexity of this is big O of n cube. Okay. But what we want is that complexity of the other one should be big O of n square. The proposed solution that I'm proposing here, the complexity of that is going to be big O of n square. And I have discussed it. Now let me show how I'm going to implement it. Once I implement it, it will be all clear and easy to understand. So let me first delete all this, okay? So let's comment this solution out. So again, we'll initialize this count value. Okay. And then what we will do that, we will also initialize n is equal to rating dot length. And then what we'll do that, for int I is equal to 0, I less than n plus I. Now within this, for every given index, what we want to do is that some values will be left less is equal to 0, right less is equal to 0, uh, left more is equal to 0, right more, that also is equal to 0. So one loop will go towards the int j is equal to 0, j less than I. Okay, so this will be giving us the count of all values, since no two ratings are the same. So rating of j would be less than rating of I. If rating of j is less than rating of I, then we are going to increment left less, else left more. Okay, no two ratings are same. So either it is less or it is more. It cannot be equal. That is there. Okay. Now same for the right hand side. For every index, to the right of I plus 1, k is less than n plus k. If rating of k is greater than rating of I, then what is it is going to be right more, else right less. Okay, and then what we'll do that with the previous count value, what we are going to do, left less into right more. What this will give, what this count will give, it will give those triplets which are going to satisfy left less and right more, is going to give this condition. Okay, right of I is less than right of j, and right of j is less than right of rating of k. Okay, so this left less into right more is going to give a count of this, and now we want a count of this, so it will be left more into right less, like this, and then at the end we are going to return the count like this, and that's how we are going to run this. Oh my goodness. Plus plus. Perfect. Perfect. Now you see it's beating so many other solutions, and it is one of the fastest solution that is possible for this problem. So I hope you like this, this ingenious technique. I also loved this technique. Okay. And this is, it can be easily seen that, the way we have constructed this solution, that in itself is a proof that this method is correct. And, it is as logical and as precise as, as correct as, any mathematical proof that we can give for this problem. So I would rather say that, this is this code itself, this program itself, this logic itself in itself is the proof that this method is the correct solution, and it is accomplishing what we want to achieve here. It is giving us the count, and the complexity of this is big O of n square. So the complexity of this whole loop is big O of n to the power 2, like this. So perfect solution. I hope you like this. Please, if you have any doubt, please post it in the comments. I would definitely love to answer all those doubts, and any appreciative comments, constructive suggestions are also welcome. My best wishes, happy coding, best of luck.